Okay, so last class we talked about our SI units, introduced what chemistry was. So now we're going to move on to prefixes. So this is a really important chart. You're going to need to know pretty much this entire chart. So let's look at this. So first we want to look at the prefixes. So kilo, like kilogram, centi, deci, milli. So you're going to need to know the name of the prefix. You're going to need to know the symbol. Is it a lowercase m, lowercase k, capital letter? And then you don't necessarily need to know this because it's hard to know like how many zeros is that, but you need to know this guy, okay? So you need to know the first column, the second column, and the third column. Now you might ask yourself, well, what are these prefix multipliers for? So in chemistry, we might talk about something that's really big in the sense of how many molecules of water are in the ocean. And then we might talk about something that's really small, like the size of one atom or one electron. So we talk about really big things and really small things. Now when I say big, I'm thinking about like how many they have, not how big, like in the size of an elephant kind of big. So quantity kind of thing, okay? So if we talk about really big things and then we talk about really small things, we need a way to kind of go from big to small. And so this is what these prefix multipliers do. So we could talk about things that are 10 to the 18th power. It's all the way to 10 to the negative 18th. So things that are really big, to things that are really small, okay? And we're gonna use these when we do conversions. So if we wanna convert from a really big number to a small number, that's when we'll use this chart. So we're gonna come back to this chart. I just wanted you to first see this chart and know that this is something you're gonna have to start having memorized to be able to use. All right, so let's start talking about a few of our measurements. So we're going to talk about 3 basic measurements in this chapter. The first one we want to talk about is temperature. Okay, so what is temperature? Now you might know, well, oh, I have to take my temperature, so temperature kind of tells me like if I'm too hot or too cold or something like that. Okay, but let's talk about what our science, our chemistry definition of temperature is. So our chemistry definition of temperature is the measure of the average amount of kinetic energy. All right, so let's kind of break that down a little bit. First word that we used was kinetic energy. So that's a word that you might not be familiar with. So kinetic energy, we can shorthand it as Ke, is the energy of motion, of moving. So the energy of motion. So if I'm taking the temperature of something, I'm looking to see how much are those atoms or molecules moving. Now, the higher the kinetic energy, the more they're moving, the higher the temperature. The way you can kind of think about this is if you're running around really fast, you get hot. But if you're not walking around as fast, you don't get as hot, right? So the more you move, the hotter you get. So kind of the same idea. So the higher the kinetic energy, the higher the temperature. And so what we're measuring is the amount of energy that is being released. And we'll talk about that a little bit more when we have our energy section. Okay? Now, let's talk about how temperature is going to flow. How does this kinetic energy move? So say, for example, I have a water bottle. And my water bottle is really cold. Nice cold, just got it out of the water fountain, feels good, okay? Now, I hold the water bottle and it feels cold. Why does it feel cold? You might say, oh, it's cooling off my hand. But we said that the temperature is the energy of motion. Now, before I talked about the motion of just me moving, but we could also think about motion in the sense of it moving from one place to another or from one thing to another. So there's an interaction that's happening between the water bottle and my hand. So the reason that the water feels cold, the water bottle feels cold, is because there's energy that is moving. My hand is going to feel cold because it's hotter. My hand is hotter than the water bottle that I'm holding. So what happens is that the energy is going to go from what's hot to what's cold because it's going to heat it up. Okay? So energy goes from my hand to the water bottle, And that's why my hand feels cold, because I'm losing energy. So one of the things we want to think about is, how does energy flow? So heat flows from the matter that has high thermal energy. So you can think of, it's going to flow from whatever has the highest temperature. So heat flows from the matter that has high thermal energy into matter that has low thermal energy. So it goes from hot stuff to cold stuff. Is how you can think about that. That could be your non-sciencey definition. It goes from hot to cold. All right, so how do we measure the temperature? We already kind of talked about that there's 3 scales. There's the Fahrenheit, the Celsius, and the Kelvin scale. So we have 3 different ways to measure the temperature. Now let's compare them. So how I'm going to compare them is I wanted to measure the liquid weight range for water. So this is the temperature that water freezes at. This is the temperature that water boils at, based on my range. So here you can see that my Fahrenheit range is 32 to 212, where my Celsius range is a little bit lower. So think about this as higher, this is kind of pulled down a little bit. Okay? And then Kelvin, see here, these are much bigger numbers. I mean, these are kind of close together, but this is a much higher scale than these. Now, one of the things that we want to talk about is, if these are my scales, what is the lowest that these numbers can go? Okay? Now, we can mathematically make them go really low. You can go all the way to negative infinity. But in a chemistry standpoint, what's the lowest that my temperature can go? And that is going to be absolute 0. So absolute 0 is theoretically the lowest obtainable temperature. Okay, so this is theoretically the lowest obtainable temperature. And so we call it absolute 0 because it's measured in 0 Kelvin. Now if you notice I said 0 Kelvin, I didn't say 0 degrees. Here for Fahrenheit we have the degree symbol, so 32 degrees. Celsius is 0 degrees, but Kelvin is just 273.15 kelvins, is what you would say. So this would be degrees, degrees, kelvins. So our lowest obtainable temperature would be 0 Kelvin. Now, one of the things we want to be able to do is convert. So say you're telling me the temperature in Fahrenheit, I need to be able to convert that in Celsius, so I kind of know what that means. Or I need to go from Celsius to Kelvin because I'm going to report my answer in Kelvin in a paper. So I need formulas to be able to go from one to the other. So here are your formulas. So if I have Fahrenheit and I want to go to Celsius, I'm trying to find degrees Celsius, then it is going to be my degrees Fahrenheit minus 32 divided by 1.8. So degrees Celsius, if I have the Fahrenheit, I'm trying to go to Celsius, here's my Fahrenheit, minus 32 divided by 1.8. Now you might have seen 9/5 before. In some of your formulas, 9/5 is just 1.8. Now what if I wanted to go the other way? This is Fahrenheit to Celsius, what if I want to go Celsius to Fahrenheit? So to go the opposite way, degrees Fahrenheit is equal to 1.8 times the degrees in Celsius, and then we say plus 32. So now I can go the opposite way. I have Celsius, I can find Fahrenheit. Now what if I want Kelvin? Now the only way I can find Kelvin is I have to have Celsius. So I can't go directly from Fahrenheit to Kelvin. I have to go Fahrenheit, Celsius, then Kelvin. So if I want to find Kelvin, Kelvin is my degrees Celsius plus 273.15. Now it's really important that you include the 0.15. Okay? And then if I'm trying to go the opposite way, degrees Celsius is my Kelvin minus 273.15. All right, so let's practice our formulas and our temperatures on the next slide. So this problem says convert 22 degrees Celsius to Kelvin and then also to degrees Fahrenheit. So the first part is asking me to go from 22 degrees Celsius to Kelvin. And then the second part says to take my 22 degrees Celsius and go to degrees Fahrenheit. Okay, so I want to go from degrees Celsius to Kelvin. So I need the formula that has Celsius and Kelvin in it. So I need something that has Celsius and Kelvin. They gave me Celsius, I'm trying to find Kelvin. So I want this first one because I'm trying to find Kelvin. I'm not trying to find degrees Celsius. So that's the one I want. So Kelvin is equal to degrees Celsius plus 273.15. I plug it in, 22 plus 273.15 gives me 295.15. Remember, no degree symbol and just big K. So 295.15 kelvins. Now, as far as how many decimal places you have to go and those kind of things, we're going to talk about that when we introduce sig figs in this chapter. But my rule is to leave 2 places at least. We don't want to round. When we talk about really, really small things, these little decimal places can make a difference. That's why they're there in our formula. So don't write 295. Write 295.15. Leave 2 decimal places. On your homework and your tests and quizzes, I'll ask you how many decimal places to put. All right, so let's do the next one. 22 degrees Celsius to Fahrenheit. So I have Celsius, I need Fahrenheit. So I'm looking for Fahrenheit. So it's not this one, it's going to be this one because I have Celsius, I'm looking for Fahrenheit. So degrees Fahrenheit is 1.8 times the degrees Celsius plus 32. Plug in my degrees Celsius. If you want to break it down and you want to do the multiplication first, 1.8 times 22 is 39.6. And then when I add that together, I get 71.6 degrees Fahrenheit. So here we use the degree symbol. Okay? So 71.6 degrees Fahrenheit. So this is how we use our formulas. All right, we're going to stop there so the videos don't get too long. And on the next video, we'll talk about volume.